So here we have that small module, that multi-component, multi-function tester. As you can see, it's now put into an enclosure, and I have included some flying leads with crop clips, as you can see there. They are colour coded. I shall zoom in a bit so you can see. Very difficult to adjust the camera. As you can see, 1 is yellow, 2 is green and 3 is white. These leads the numbers will become apparent later. I have included in this enclosure a power supply for charging the battery. It has a 9-volt rechargeable battery in there. I have also included a switch to switch between the battery and the charger. So let's see what this little unit does. I have put in a 200k resistor. Let me zoom in onto the display, and as you can see, it's reading 201k. Sorry about the camera being a bit jerky at the moment. It's now gone off. As you can see, it's reading 201k, and it's connected across the terminals 1 and 3. Here is a 1000 picofarad capacitor, and as you can see, it's come up at 981 picofarads. This little unit is not, I would say, very accurate, but it does give you an idea, or roughly near to the. I have now put in a 22 microfarad capacitor. As you can see, it's come up with ECR, it's come up with V offset. Well, I don't know what these are, but it's come up as 23.13 microfarad. Now, being a 22 microfarad capacitor, it's not that far out. Here is a 220 millihenry inductor. I'm not sure. Oh yes, it's come up with 0.19 microhenry, no, millihenries. It's a 220 microhenry, so that's showing 0.19 millihenries. So it's, well, I'm not sure what the tolerances are on these inductors. Now let's turn to a transistor. So I shall put in this. This is a PNP transistor. I know what it is, but let's see what this little device does with it. And there you go, it's a PNP transistor. Now the base is on connection 2, the collector's on connector 3, and the emitter's on connection 1. And this is why these leads are coloured, because number 1 is yellow, number 2 is green, and 3 is white. So if you've got a semiconductor connected to the leads, then you know what these numbers correspond to. So that is a PNP transistor. Here I have plugged in a field effect transistor, and it's coming back showing a NEMOS. As you can see, this is a field effect transistor. Now the interesting thing is you're seeing that the gate is on number 3. So if I reverse this, put it in the other way, we press the button, you now see that the gate is on connection 1. So it doesn't really matter what way you put the device in. Okay, I have now plugged in. Well, you will see, there you are, it's a thyristor. And yes, I know it's a thyristor. But if it was an unknown device that you didn't know, this thing will tell you exactly what it is. The thing I find most useful about this device is that I have a box of transistors which I don't know what they are, whether they're NPN, PNPs, I don't know. But thanks to this little device, it will now tell me. As you can see now, I have connected a power transistor to the leads. This is a 2N3055 common audio power transistor. And if I come back to the display and zoom in slightly, there we are, it's an NPN. The base is on connection 2, and connection 2 is the green lead. So now we know that the green lead is the base, and yes, it is. I have now connected another power transistor to the, there you go, it's another 2M3055. Now let's push the button and see what happens. Oh dear, what do we have here? It is showing a resistor. That is not correct. I have discovered an anomaly. Now, the interesting thing is, if I put a 47k resistor across between, what was it? I think it was 2 and 3. Yes, 2 and 3. If I put a resistor across between 2 and 3, and test that again, it is now showing an NPN transistor. So why, when I put a 47k resistor across 2 and 3, it shows correct? Now I have found this on some occasions. Now, is it due to the makes of the transistors with having different parameters? And this device is programmed for certain parameters, and if a device falls out of those parameters, it shows wrong. But as I say, that I've discovered by putting if it comes up with a resistor like that, by putting a resistor across those terminals, it obviously, because you're putting a resistor across another resistor, it lowers the resistance. And that obviously brings that transistor back into the parameters that this device understands. I wonder if anybody else has discovered this. I know that there are a variety of these different devices around, and I wonder if the software is different for each device. But I thought that I would show you this because it is a strange phenomenon. Anyway, I hope you like this video, and I hope you like what I've done with the little box. And there will be more videos to follow later. Please note that all the devices I have tested here have been tested on other devices and are all completely okay.